Okay, so a very good evening to everyone. And also a very warm good morning to Sumit, who's joining us from the US. So, today we'll be focusing on how artificial intelligence can be harnessed for the true public good. So, our guest organization for today's session is Longtail AI Foundation. They are a Noida based nonprofit dedicated to bridging the digital divide. They design AI tools specifically tailored for societal well being and for the underserved communities mainstream technology frequently overlooks. So, one of their standout initiatives is Talk in ISL, that is Indian Standard Language, developed in close collaboration with the Noida Deaf Society, a pioneer that has spent more than 20 years enabling deaf adults to gain independence and sustainable careers. So, now I'll hand over the session to Longtail AI Foundation.
Hello, Emmy. Thank you for inviting us, and we are very happy to be here to talk about our work, Science of Progress, AI for Indian Sign Language. Uh, we started this work roughly 2 years ago with the broad goal of making the internet accessible to the deaf community with easier communication with the hearing community and easier content creation and consumption. We are doing this by building bidirectional translation systems from Indian Sign Language to English and from English to Indian Sign Language. One of the most rewarding parts of the journey has been getting familiar with the news and culture of the deaf community. For example, we worked with a deaf person who did a like very long distance drive all the way from like somewhere in North India to Kanyakumari. That may sound unremarkable until you think about how much of Indian driving relies on the horn. This wasn't an easy journey to make. Only recently, deaf Indians won the right to drive after long and hard work from deaf advocacy groups. So, even though both me and my father are hearing, these stories inspire us to continue on our journey. So, as part of these efforts, we have built a Learn ISL app. On the left, we have integrated it into WhatsApp. It lets you practice, look up signs, and even like practice them. So, here's a demo that I'll play through. So, the app suggests a few options that you can do in it. I'm going to search for a word. I'll start simply with hello. It will show me a clip of the sign, and then I can try it myself. So all of this is in WhatsApp, and this is me. I quickly did a sign and uploaded it. Because of how quick I was and the quality of the video, you will realize that our model wasn't able to catch it. So this is work in progress. But if I try again and this time do it more slowly and like a few times, then our model is able to pick up the sign and then give you feedback on how you have done it. So this can be a great way to keep up with your practice as you learn sign language. And here is our QR code for the WhatsApp app. Uh, please check it out. On the right, we have also a full version of the app, which is on the web. This has features to track progress, do daily challenges, and so on. As I mentioned, everything here is a work in progress, and we'd love all the feedback we can get. Okay, so rest of the talk is going to be technical, and we'll talk more about how we are actually building these systems to solve bidirectional translation between sign language and English. So, the dominant paradigm in machine learning is scaling data and compute. And we think that automatic translation is bottlenecked by data. So, consider a qualitatively similar task of speech transcription. So, this is not a perfect analogy, but it's still worthwhile to think about. Methods like OpenAI's Whisper only succeeded because of the troves of audio data sitting on the internet, conveniently paired with text. This kind of data simply doesn't exist for Indian Sign Language. So the dominant paradigm in AI right now of scaling data and compute isn't available to us. Here we have plotted the data scaling law from Whisper to do a little thought experiment. On the x-axis, we have hours of labeled training data, and on the y-axis, we have the word error rate, which is the fraction of words in a transcription that come out wrong. We take the numbers Whisper reported and fit a scaling curve. This is the bold line. Then we extrapolate the curve to the amount of available Indian Sign Language data there is. For reference, we use Ish News, which is a YouTube channel with high quality signed and captioned data. This data is a lot, but only 697 hours. And if we extrapolate this curve, the line goes out of chart. So we get a word error rate of 124%, which is obviously nonsensical. This shows that the scaling paths that has brought us LLMs isn't available in our domain. So unless someone hands us another 680,000 hours of data, we have to think differently. Luckily, the good people at the VGG group in Oxford, so Professor Andrew Zizerman and Professor Gulvarol, have shown us a path forward. They have been working on British Sign Language. Their approach is not to attack translation head on. Instead, they build up through simpler related tasks such as sign spotting, isolated sign recognition, finger spelling recognition, etc., and bootstrap from there. Following that research program, their most recent work, shown here at the bottom, shows automatic translation of news videos and even harder cases like a conversation between two people who are signing. We are following a similar pipeline adapted to Indian Sign Language. We are gradually collecting data and improving our models in a loop. We mine sign instances from news videos, have experts who are deaf signers and interpreters verify what we have detected, and then retrain on better labels, which lets us mine more. So, Ish News, which I mentioned earlier, carry both a signer and English captions that are roughly aligned in time. So, if we want examples of a particular sign, the caption tells us roughly where to look, and we only have to find the exact moment. So, here are what the steps look like in more detail. So, first we localize the signer. We exploit a simple cue. Signing involves far more hand movement than anything else on screen. So we run pose estimation. Sustained hand motion tells us where the signer is and we crop to it. Then we use captions to narrow in a long video. So say we want examples of the sign hello. We look up where the caption says hello. That alone takes us from 4,000 frames to a 500. That's still too many. So we have this idea of score windows where we take a single reference clip, slide a short window across the region, and score visual similarity at each point. The minimum distance gives us a candidate. So here we have picked out a candidate which is doing the sign of hello. So we have localized this from around 4,000 frames. We repeat this at every occurrence of the word across the corpus and get a ranked set of candidate detections. These go to our deaf annotators and interpreters for verification. This is our labeling interface. The annotator sees the candidate detections for a word, again continuing the example, we are using the word hello, and accepts or rejects each one with a click. Green means accepted, while leaving it as is means you reject it. So here, four signs are accepted by the labeler, while the last one isn't. With this label data, we train our model to improve our accuracy. A dictionary clip of the sign goes through a video transformer. The candidate clip goes through the same network with the weights being shared. We combine the two vectors along with their difference and their product and use an MLP to obtain a score. Training comes from the annotators. So this pair was accepted while the following one was rejected, even though the model scored identically. We use annotated labels to tell the model to do better next time. So this completes our mining loop. The mining, labeling, and training loop runs 3 times. We track two numbers, how many dictionary words we can mine at all, and what fraction of candidates get accepted. This is on the right. Thankfully, with each execution of this loop, we improve on both counts. So by executing this loop 3 times for a 60 for a vocabulary size of 1680, we mine roughly 10,000 instances, which is a cumulative total of 3.4 hours of labeled sign language data. News gives us a lot of signing, but it's all done by a few signers in a studio from one camera. To avoid overfitting our model to this corpus, we additionally capture isolated signs ourselves with a motion capture Rococo suite, where rather than recording the video, we record motions. So this video shows my father and our collaborator doing motion capture with this suit. In this data, we capture 6,000 signs from four signers. And the benefit of this is that we get infinite variety. Since we have the motion, we can put various avatars on top of them and render signs under diverse lighting and viewing configurations. So here is a boy signing chili. Even if you don't know sign language, you can clearly make out what is happening here. The benefit is that once we have the motions, we can just keep going. We can play different clips or different gestures on these avatars and also have a wide variety of avatars in these environments. Using this data, we can train better sign recognition models. This is to show my claim of infinite variation. The mocap data isn't only for recognition. We can use it for going from English to Indian Sign Language too. This other direction is arguably more useful for the deaf community because almost everything on the internet is text and none of it is signed. Our current pipeline is English to gloss, a written sequence of which signs in what order, which we get via an LLM. So, for example, if we have a English sentence of my family goes to a restaurant for dinner, an LLM tells us which of the words will actually be signed. So, family go restaurant eat dinner. Then we gather the corresponding motion capture clips for each of these words. So here I'm showing an animation of just the motion and we stitch them together. Once we have this, we can simply put an avatar and animate it. So, hopefully, we have given you a good sense of what we are doing. We have a lot of challenges we haven't spoken about here. Firstly, we haven't adequately addressed grammar. Sign language uses space with pointing and indexing to refer to concepts. Stitching isolated signs or focusing on just nouns and adjectives alone can't handle this. Secondly, our English to gloss pipeline isn't validated. We produce plausible gloss sequences but aren't sure whether deaf persons actually sign like that. Finally, our data comes from interpreters. There is a difference between interpreters and native sign language signers, and closing that gap is central goal in our work. So, with that, I'd like to wrap up. Thank you for having us again. Here's the QR code for our app, and we'll be very grateful if you can try it out and give us feedback. Thank you.
Thank you so much, Sumit, for that session. So we'll now open the floor to any questions. Okay, I'll ask one question. So, what exactly inspired Longtail AI Foundation to focus specifically on Indian Sign Language?
Uh, Papa, do you want to answer that?
Uh, well, as Sumit said that, sign language and the deaf community is an area where, there is a lot of opportunity for research and, using artificial intelligence to resolve the challenges of communication for the community. And, a few attempts have taken place indeed in this area, given that sign language is such a visual medium, then it immediately comes to mind that the artificial intelligence and machine learning should be able to help here. But I am not very sure if those sustained efforts have been made or if how successful those have been. There are a few sort of organizations which are also working in this domain and have made some good progress, but we continue to feel that, yeah, I mean, this is a community which is underserved as of now. And, with the sort of availability of such tools, uh, they can better utilize what is available on the internet and sort of, use internet and the learning abilities that it provides to the fullest. Uh, that is the motivation. There is no other specific reason for picking up this area. Just think that this is a ripe area where AI, ML, etc., and LLM can certainly be helpful to solve this issue.
Thank you, Sufrat, for that answer. So, you also mentioned some challenges in building ISL for AI systems. So, can you just mention like one challenge that you faced so far?
Uh, right. So, as I mentioned, like the dominant way in which people try to solve problems with AI are to collect a lot of data, and unfortunately, due to like the small presence of the deaf community on the internet, there's not a lot of data. So we have to come up with devise our own labeling strategies or our own uh, methods that can cheaply gather a lot of high quality data that we can use to train our models and solve the problem. Another challenge is that there's a lot of like domain gap between our understanding of sign language and what is actually happening. So finding collaborations is always like important for us. So for example, some of the things that I spoke about in terms of like understanding grammatical constructs of sign language, uh, those are challenging for us right now to attempt because we are still building our understanding of the language, and so yeah.
And that is the most critical point because you see, I mean, sign language is just yet another language, just like spoken languages, right? Although more visual. And it has its own grammar. And the challenge that we see is that, just by stitching gloss stream sort of science together does not make it a proper sentence, right? So you have to sort of follow the grammatical structure of sign language, and that varies just like any language, right? I mean, there are just so many variations, possibilities, and that causes a big challenge for us to kind of get to it.
Okay, so I don't think there are any more questions. If there are, I think you can just type in the chat box as well. So I think what I believe that what you guys are doing is very inclusive and not a lot of. I haven't, as far as I'm concerned, there are not a lot of organizations or NGOs that are doing what you guys are doing. So that's very it's very good. It's a very good initiative.
Thank you.
Thank you.
Indeed. Actually.
So if there are no more questions, I think we can end this session if that's okay with you.
Yeah, perfectly fine.
Okay, thank you so much once again, Longtail AI Foundation. So for such a wonderful and informative session. So we truly appreciate you taking the time to share your insights with us. And we wish you all the best with your future endeavors. And we hope to collaborate with you again on future projects.
Thank you, Amy, and thanks
So
for
thank you,
having
Sufrat
me.
and Sumit.